Hi everybody, for this month's maths video I've got a little puzzle for you. Take a look at this. You might have seen puzzles like this before. The idea is to put your pencil on the paper and keep it on there while you draw this shape, but you're not allowed to go over any line twice. Is it possible? Well, I'll give you a few seconds to decide, but you probably want to pause the film while you have a think. Well, how'd you get on? Sadly, you probably discovered that it is in fact impossible. Okay, well, let's not get too disheartened. Here's another one for you to try. Check it out. Now, straight away, I'm going to tell you this one is possible to do. But why? What makes this one different? Because, if anything, this one seems more complicated. Well, again, I want you to pause and have a go and keep going till you've done it. Okay, this isn't a race. This is just about giving us some time to think mathematically. Okay, here comes one possible solution. I start at the bottom, up to the middle, back down and across. This is not the only solution, it's just one that I've come up with. Across we go, and then up, down, and down to the bottom. I wonder which solution you found. There are several ways of doing it. I couldn't possibly know which way you did it, obviously, but what I do know is if you succeeded, you started at the bottom and you finished at the bottom of the other side. Am I right? To find out why, we're heading off now to Dublin, the capital city of Ireland. Let's go.
In the year 1735, a mathematician called Leonard Euler went for a walk. What he discovered would change the history of mathematics forever. He invented a whole branch of math we now call topology. Just take a look at the mat down here. What appears to be a map with some bits of rubber on is in fact a map of the town of Konigsburg where Euler was. And you can see there are 4 different regions, islands, and the only proper way to cross between one island and another is by crossing the bridges. Now, what Euler wondered to himself was, could I cross each and every bridge once and one time only? Well, a few of us today here at Maths Week Ireland have been trying to find out. Let's take a look.
Well, it can't be done, and here's why. Look at this diagram. Let's take each of these points to represent one of the islands, and each of the numbers as the number of bridges that reach it. Now, Euler's genius was to realise that as long as you had an even number of bridges, you could go on or off as many times as you needed. But if you had an odd number, you could only go on and off once, because the second time, of course, would either be on or off, but you couldn't escape. Therefore, argued Euler rather cleverly, I can start and I can finish where there is an odd number of bridges, at a node they were called. But therefore, if there are more than 2 with an odd number, I can't. Now, let's take a look at the map again. If you look at these islands, you can count the bridges. There we go, 3, 3, 3 and 5. In fact, not one of them has an even number, and that's why it was impossible. For your challenge, why not try and draw a picture of what this would look using just points and lines? It's not as simple as it first appears, but hey, you're smart.